Let's try to find a rational function with the following properties. And we're going to, again, identify where these characteristics belong. If they belong in the numerator, which is the top, or the denominator, which is the bottom of our rational functions. So first one is an x-intercept of -2, 0. X-intercepts come from the numerator. Whole at x equal to 1, we get a whole because we canceled something out from top and bottom, which means it comes from both. We have vertical asymptotes at x equal to -4 and x equal to -1. Vertical asymptotes come from the denominator. We have a horizontal asymptote of y equal to 0. Remember, if we get y equal to some number that's not 0, then the degrees are equal. But when we have a horizontal asymptote of y equal to 0, we bottomed out, which means that the degree of the bottom, or the degree of the denominator, is bigger. Bottom out. Okay. All right. I'm going to go ahead and write my function f of x equal to, give myself some space. You may be going, why is she not doing anything with that y-intercept? Remember, y-intercept comes from when you plug in x equal to 0, and here we would get y is equal to 1/10. We're going to use that to check our function at the very end. Let's go back and find our factors. We have an x-intercept of -2, 0. That tells us that x is equal to -2 because x, y in the ordered pair. And that tells us our factor is x plus 2. We said the x plus 2 needs to come from the numerator or the top. So let's go ahead and put the x plus 2 up top. We have a whole at x equal to 1. That tells us our factor is going to be x minus 1. And we said that needed to show up in both top and bottom, or both numerator, denominator. So we're going to have x minus 1 up top and x minus 1 in the bottom. We have vertical asymptotes of x equal to -4, which gives us x plus 4. And when we have x equal to -1, that gets us x plus 1. And these were our vertical asymptotes, so they are going to be plugged into the denominator. All right. Says that we need a horizontal asymptote of y equal to 0. We know the degree of the denominator needs to be bigger. So if we check the degree of the numerator, we have 2, factored form polynomial, add the exponents. And in the degree of the denominator, we have 3 for the same reason, adding up all the exponents. And we know that 3 is bigger than 2. So degree of the denominator is bigger. Cool. We have a horizontal asymptote of y equal to 0. Now we're going to double check that whole y-intercept thing. So let's plug in 0 every time we see an x. And from there, we can see if we get that 1/10. So instead of x plus 2, we're going to have 0 plus 2. Instead of x minus 1, we're going to have 0 minus 1. Gotta plug 0 into the bottom as well. So instead of x minus 1, again, we have 0 minus 1. Instead of x plus 4, we'll have our 0 plus 4. And instead of x plus 1, we'll again have 0 plus 1. Let's go ahead and try to simplify and do the arithmetic. Up top, we would have 2 times -1, which gets us -2 up top. In the bottom, we would have -1 times 4 times 1, because the zeros don't do anything for us, which gets us -4. When we reduce, that gets us a positive 1/2. That's not the 1/10 that we want to get to. So we have 1/2. We need 1/10. So you may be thinking, well, how can we do that? We can't add in any new factors because that would change our asymptotes and intercepts, all kinds of different things. But we still need to get from 2 to 10. We can't add because notice factored form has everything multiplied. Wait, everything multiplied. We can multiply 2 by 5 to get 10, which means if we multiply 1/2 by 1/5, we would get 1/10, which means we need to add in a 5 in our denominator. So adding the 5 into the denominator, we're going to have f of x is equal to x plus 2 times our x minus 1, and our x minus 1 starting us out in the denominator. I'm just copying all of our factors down that we already had. We had x plus 4 and x plus 1, but we said that we needed a 5 in the denominator, which means we need a 5 in the denominator of our function. And we have our final answer. So this time our y-intercept helped us figure out that we were missing a constant or just a plain old number in the denominator.